What I want to do in this video is think about how far can I see from the window of a plane when a plane is at its cruising altitude. And just to give us some numbers to work with, let's just assume that the cruising altitude that we are working with, the altitude of the plane is 10 kilometers. And the number for the radius of the Earth, and so this will be important for figuring out how far I can see from the plane, the Earth's radius, let me do this in a different color. The Earth's radius, do it in green, Earth's radius in kilometers is 6,371 kilometers. And it's actually not constant throughout the Earth, but we're going to assume that for the sake of this problem, that Earth is a perfect sphere. It actually is not one, but we will assume that it's a perfect sphere. And its radius is roughly 6,371 kilometers. So given this information, can we figure out how far can we see on a perfectly clear day from the window of a plane cruising at an altitude of 10 kilometers? And I encourage you to pause this video and try to think about it on your own. So I assume you've given a go at it. So let's draw Earth. Let's draw Earth. And this, by no stretch of the imaginations, will be a scale drawing either of Earth or of the plane flying above the surface of Earth. So let's say that this right over here is Earth. I would want to draw it as a perfect sphere, but I have not. But you understand my limitations. Now let's see what we could do. So the plane is traveling at an altitude of 10 kilometers. So let's say that this is the plane right over here. And this distance, once again, by no stretch of the imagination drawn to scale, is 10 kilometers. 10 kilometers. And then if we were to keep going down to the center of the Earth, that would be another 6,371 kilometers. And when you think about how far you could see, your line of sight is really forming a tangent with some point on the surface of the Earth. So this is me and my plane. And let's say I'm looking at that direction. How far could I see? Well, I'm going to be hitting the surface of the Earth at some point, and that line of sight is essentially going to be tangent to the surface. So let me see if I can draw it a little bit cleaner. So let's see, it's going to be tangent to the surface. So it's going to look something like that. And so this is the furthest point I could see, the point at which my line of sight is just tangent to the surface of the Earth. Well, how far is that point of the surface going to be from the center of the Earth? Well, we're assuming that Earth is a perfect sphere, so that's also going to be 6,371 kilometers. So that's also going to be 6,371 kilometers. And the other thing we know is that a tangent line is going to be perpendicular to a radius. So this right over here is going to be a right angle. And all sorts of bells should be ringing in your brain at this point because we have just constructed a right triangle. And what we want to figure out how far we can see, well, that's this unknown side of this right triangle, this side that I have marked in X. So we can just use the Pythagorean theorem. We know that the square of this side, so x squared, plus the square of this other non-hypotenuse side, so 6,371 squared, is going to be equal to the square of the hypotenuse. So what is the length of the hypotenuse? Well, the hypotenuse is 6,371 kilometers plus this extra 10 kilometers of altitude, squared. And so we get x squared, I didn't know why I wrote that in yellow, but anyway, x squared plus 6,371 squared is equal to, what is this going to be? This is going to be this whole distance right over here. The whole distance is just going to be 6,381 kilometers, and we're going to square that. So x squared, if we just subtract 6,371 squared from both sides, we get x squared is equal to 6,381 squared minus 6,371 squared, or we could say that x is equal to the square root of all of this business. And I could just copy and paste that. So copy and paste. Let's throw that right in there. Actually, my radical is not big enough. So let me make my radical a little bit bigger. Let me make my radical a little bit bigger. And then we can use a calculator to actually compute this. So let me get my calculator out. And this is exciting because now we can finally know on a perfectly clear day how far we can see out of a plane. So it's going to be the square root of 6,381 squared minus 6,371 squared, which is going to be, we deserve a drum roll, it's going to be 357, roughly 357 kilometers if we round to the nearest kilometer. So x is approximately equal to 357 kilometers in any direction. So you can see 357 kilometers in that direction. You could see 357 kilometers in that direction. So if you were looking at a map, of, say, well, let's say you're looking at a map of the US and your plane is flying across it, and this is kind of neat. So let me, and once again, this is by no means drawn to scale, but let's say that this right over here is North America. Let's see, that's the Yucatan Peninsula, that's Louisiana, I'll draw Lake Pontchartrain right over there. And then, see, that's Florida, and then that's the rest of North America. That's California, just like that. It's Vancouver. Well, I could keep going, Alaska, so on and so forth. So if you're flying in your plane is right here. If we assume the numbers we just assumed in any direction, you can see 357 kilometers. So 357 kilometers would be about that far. So you could see that far in every direction. So it's kind of like seeing an entire state, or actually multiple states, depending what state you're thinking about, of the US from your window. If you could look in every direction, obviously if you're only sitting on one side of the plane, you can only look out of one window, but maybe you could go switch to the other side of the plane and see the other side as well. But you're actually seeing a substantive area when you look out of the window from 10 kilometers, which is roughly about 32,000 feet in the air.